First, I would like to thank you for the opportunity to come here and present the work that I'm doing at the Ministry of the Environment. I didn't understand my introduction, so I'll say a few words anyway. I'm a professor at the University. I know Mike for, I think, more than 10 years now. And I just returned tonight from a month at Harvard University, and I left this day free because I said I have to go get over the jet lag. But being invited here, I said, is more important, so I'm here, and I apologize if I'm not that coherent as I'm usually speaking. So I want to tell you about this tool that I'm developing at the Ministry of Environmental Protection, the Climate Adaptation Portal, which is a tool for supporting more decision and knowledge-based decisions and actions for adaptation to climate change. And the reason I started this work is that one of the roles of the chief scientists of the ministry is to make sure that decisions are based on knowledge and science. And I joined the discussions on adaptation to climate change, and I realized that there's not much knowledge. So there is knowledge around, but it's spread among many different bodies and entities in different ministerial ministries, in the academy, in the private sector. It's very difficult to collect all this information, and once you have all this information, it's really difficult to analyze it and get to decision from all these huge amount of data. And you also have to understand the subject matter, so you have to understand the methodology, in environment, in welfare, in health. There are many subject matters that have to be taken care of. But why do we actually need climate adaptation? After hearing the high school students today, I think that my introduction is unnecessary, so I'll do it really quickly. So as you all know, our world is at risk. What you see here in the figure is the number of disasters, world disasters, and you can see that there is an increasing trend. It's continuously increasing, and by 2030, global disasters could increase by 40% compared to 2015, not that long time ago. This means that we will have about 560 disasters per year, which is more than 1.5 disasters per day. So the disasters that we see today, flooding, fires, will be a day-to-day thing that happens, and it won't get to the news because it will be so frequent. Then the number of extreme temperature events is increasing and will almost triple from 2000 to 2030. The number of drought is increasing and will increase by more than 30% between 2000 and 2030. And this results in high economic loss. And you can see here the losses from climate and weather-related events. In red, for comparison, you can see geophysical disasters, and you can see that the geophysical disasters are not increasing. So the increase in the economic loss is not because the economic is increasing, it's because we have more disasters, and all these disasters are related to climate change. And the impacts are not only economic. You know that there's also impacts on ecological systems and on social systems that we don't see here in this figure, and sometimes these losses are even worse than the direct economic. And unfortunately, this is not going to change. Not for sure, not until 2040, because what you see here in the figure is the predictions of the IPCC. In red is the increase in average temperature, business as usual, so if we don't change anything. And in green is the most optimistic scenario, which is that the world will be able to keep the temperature increase below 1.5. And yet, even if we succeed in this, you can see in the green line that the temperatures are still increasing until 2040, so there is no reason to assume that all these trends that I showed you are going to increase. And this is why in Glasgow, one of the most important conclusions was that we have to look not only on mitigation, reduction in fossil fuel usage and reduction in greenhouse gas emissions, but also we must adapt. And poor countries, poor populations, low socioeconomic levels are going to suffer the most. And these are not the same populations that produce the greenhouse gases, and we have to take responsibility and start preparing for these crises. And going to show them, that in the IPCC, every decision, every conclusion has to be accepted with all members voting. So the conclusions are necessarily some sort of compromise between the extremists from both sides. There's one group, Climate Action Tracker, that used to be a part of the IPCC and left because of this. And what they do is they take the NDCs, the nationally determined contributions to greenhouse gas emissions, or how much we are planning to reduce our greenhouse gas emissions, and calculate what the temperature will be. So I looked at the trends when we were in Glasgow, and they published another report when we were in Sharm in COP28. And the only thing that changed between Glasgow and Sharm was the date. Nothing changed. The numbers are exactly the same. So we are not on the right track. We are now continuing almost as business as usual. CO2 concentrations in the atmosphere don't show a decrease. They don't even show a decrease in the rate of increasing. So we shouldn't be optimistic. We should start adapting and getting ourselves more resilient to climate change. And this is another figure from the report of the IPCC showing that not only that the climate risks are higher, they last longer and they occur sooner and at a larger scale than previously expected, and the effect of each degree is higher than the IPCC expected before. And this probably is a result of the need to get to an agreement when publishing the reports. So the reports are always milder than reality. And this is not only scientists. So you can see here the result of a survey of over 12,000 country-level leaders that were asked to identify the risks, the critical risks, to their 124 countries. And you can see that climate action failure is the highest. Extreme weather, biodiversity loss, and natural resources crisis, and also human environment damage are all connected to climate change. And this is the report of the World Economic Forum. So these are already people who work in finances, and they understand that this is the most important issue that we have to deal with now. So what are climate hazards or risks, and what are we exposed to? So when we look on a risk, it's not only the risk itself. So the risk is, we have to look not only on the risk, like fire or flooding, we also have to study who is exposed to this risk, or what is exposed to the risk, including socioeconomic factors, property and infrastructures. We have to look at the hazard itself, the probability to experience a certain intensity of the hazard, and the vulnerability. The susceptibility to damage and of assets exposed to the forces generated by the hazard. So if they can withstand the exposure, and if they can overcome it afterwards. And we know what to do to reduce each of these variables. So we can, for example, reduce the vulnerability by finding insurance solutions, or build hazard-proof houses, And in each of these parts of the risk, we can take action. And in many of them, these are available solutions that we can take now. And still, when we look at the report of the UN on the adaptation gap, we see that we are doing much too little and too slow, and we are actually putting our lives in danger. And the question is why? Why, if everyone already understands and accepts, or maybe not everyone, but many, and if the financial sector, which is the most difficult to influence, is already accepting that this is the highest risk for the next 5 to 10 years, why nothing is happening? And one of the reasons is that we need high-resolution information. All these variables that we've seen until now change in spatial and in space and in time. So all the three, the hazard, the exposure, the vulnerability, they all show a high spatial resolution. And if we want to prepare ourselves, we have to understand what is the specific risk that we are facing in a specific place. There's no one-size-fits-all. And to answer these questions, we are developing this climate adaptation portal. And our aim is to optimize climate change adaptation decision-making across all sectors and use cases from municipal planners to operators. And what we are trying to do is develop a vulnerability indices, which in a very simplistic way result from the exposure times the sensitivity divided by the adaptive capacity. And the result will be maps of vulnerability, and if you see high vulnerability, you can dive into the map and understand what are the sources of the vulnerability, including IPCC scenario-based forecasts. So just to show you two examples, we started working on two risks. One is heat load or exposure to high temperature, and the vulnerability can be economic, health, mission continuity, or environmental. And we can map sensitivity, and these are just examples for different sensitivity. For example, we know that people over 70 are more sensitive to heat stress, and the adaptive capacity, what we can do, for example, the tree cover in a certain area, the use of electricity to reduce exposure to the heat, and many other options. And the same way we can look at flood vulnerability, and I'm not going to go into it because we don't have much time. I'll just show you two examples of such maps. So the first is the urban heat islands vulnerability map. So what we did was created the exposure map. So I'll just say something before. So when I started working on these maps, I realized that even without climate change, we don't have such maps for current conditions. So we started with current conditions, which already influences decision making, and I'll show you how. So what we did was measured the temperature. We worked with one of the army units, and we asked them to pick 2 time slots, which are good proxies for the development of urban heat islands. And I will show you that one of the slots we chose was 9 p.m. at the 1st of August. And the reason is that August is the warmest day, and at 9 p.m. the temperature in open areas surrounding the city is already starting to decrease, and the difference between the temperature in houses, especially in houses that are in areas where urban heat island is going to develop, is the largest. So what we did was mapped the temperature at 30 by 30 meters resolution for all Israel, and then measured the difference between the 10 kilometers surrounding each city and all the city itself. And as a sensitivity measure, we chose the density of old people over 70, and adaptive As adaptive ability, we chose the socioeconomic level. And the reason is that if the people exposed are at high socioeconomic level, they can simply turn on the air conditioning and order takeaway from the restaurant. They don't have to walk to buy their food. They have double glass windows, and they're actually not exposed to this high temperature. But if these people are at low socioeconomic level, they can't turn on. They have to save energy because they can't pay their energy bill, or they don't have an air condition, or they have to go out and buy their food and walk in the streets. They're at higher risk, and their adaptive capacity is low. So just to show you some results, I can show you your settlement if you want. I brought my computer with me, so if you want to look at your place, we can do it later on. So this is Tel Aviv. And these are the temperatures. So the average temperature of the open areas around Tel Aviv was set at 0, and the colors are temperatures that are above the surrounding. And you can see here in North Tel Aviv an area that is exposed to high temperatures, for example. This is the elderly population density, and this is the socioeconomic level. And if we combine everything together, we get this urban island vulnerability map. And let's just dive to two examples. So this is the North Tel Aviv, the high temperature exposure. But these people Okay, so this is not the right area in Tel Aviv. It's more. And somehow the circles move. So we see that they're exposed to high temperature. There are old people in this area, but they are at a very high socioeconomic level, and therefore we don't see high vulnerability here. On the other hand, if you look at Bat Yam, for example, there's high vulnerability here, but the temperatures they are exposed to are not that high. And the reason is that there are a lot of old people at low socioeconomic level. So now I can very easily go to the mayor of Bat Yam and tell him, look at the old people in this area. And the solutions that he can take are several. So for example, we can, if the meteorological services are saying 2 weeks from now there's going to be extreme heat, we can finance their electricity bill. Tell them that for this week you're not paying, turn on the air conditioning. Or we can finance air conditions. And in the long term, we can find solutions like shading, planting trees, green buildings, to reduce the urban heat and reduce the temperature for a long term. And I'll skip this and I'll just show you what happens in floods. We did very similar things. So this is acre, population density, and you can see again that the areas that are most sensitive are not necessarily the areas that are exposed to flooding. So in flooding, we took the half-meter threshold because insurance companies said that flooding below half a meter is not that expensive to cover because it doesn't get to the electricity sockets, it doesn't get to the tables, and it doesn't ruin cars. But if it raises above half a meter, this is much worse. And you can see that, again, we see that different areas are... sorry? I think that... No, this is up. So again, if I'm a mayor and I'm getting this map, I can do 2 things. First, I can say that if we have a storm in 2 weeks, I can ask the people to clean the drainage to work according to the heat map. So go first to the most vulnerable areas. And then on the longer term, I can do 2 things. I can fix the drainage areas, or increase the drainage capacity so there won't be flooding in this area. And I can also use nature-based solutions, for example, by holding you see most of these are coming from the open areas. It drains all the water from open areas, so I can find solution upstream before the water is getting into the city and reduce the amount of water that gets into the city. So the product is not only the maps. Eventually, this is Kiryat Gat, for example, and eventually what I want to have is a map that when a mayor gets this map, he can press on this red area and understand what are the variables that contribute to the vulnerability level, and have a response kit driving and assisting users to act and prepare action plans. And in the response tool, people have a lot of information, including the relevant governmental decisions and funding sources. And just to give you a very quick example, for example, if you want to look at the heat waves and health, these are daycare facilities of children below 3 years old. And you can see that some of the daycare facilities are located in urban Italy, and we can go to this specific daycare and reduce the temperature. Just skip maybe all this and say that one important thing is that mitigation and adaptation are dealt today in silos. There are people who are working on adaptation and people who are working on mitigation, and we have to work together. So because some solutions for mitigation increase greenhouse gas emissions on one hand, on the other, some adaptations to reducing emissions harm the ability to adapt. So we have to work together and find solutions that help both avenues. Thank you.
Really, I don't understand what the type of correlation between the hot zones and the socioeconomic status.
Understand. So there are two different directions. One direction is that when there is extreme heat, what we do is turn on the air conditioner and don't walk in the street. But if you don't have money for electricity, or if you don't have an air conditioner, or if you have to walk and buy your food, walk to the market and buy your food, you're exposed to these high temperatures. So low socioeconomic levels are actually exposed more to the heat. And this is something that's relatively easy to deal with if you know who these people are and where they're located. So this is one thing. The other thing is that low socioeconomic level usually live in houses that are not that isolated from heat. So they don't have double windows, they have very thin walls, and the temperature in their houses are usually very similar to the outdoor temperature. Gardens with trees reduce the environmental temperature, and low socioeconomic levels usually don't have developed gardens around their houses. So all this together creates a dangerous situation. And we also did a study showing, so there were a lot of models that were developed to estimate excess death from corona, because you couldn't make it, if so many people who died from corona died because they had background illnesses. So to differentiate how many people died from corona, the Ministry of Health developed models that measure the predicted death and compare it with the actual death. It doesn't matter from what these people died. And then this is how the number of excess deaths from corona was calculated. So we did the same thing with heat waves in Israel. We took the last 10 years, took the corona model that was developed, and tested if we have excess deaths on the weeks of heat in the last 12 years. And we found that in each heat wave, we have more than 50 people dying in Israel, each heat wave, and most of them are over 70. So this is something, dying from heat is a horrible death, and this is something that